and start the recording. Alrighty, so good evening, everyone. Welcome to tonight's Thursday session of Delta Evening and Weekend Platoon. So today we've got a couple of things on the agenda. So first, I know in the chat you guys mentioned that you all wanted to go over Boggle. Did anyone have any specific questions about Boggle before we kick things off, or just like go over the whole thing?
I didn't have any specific questions. Be more of nice to see someone who knows what they're doing do it. I've just been watching videos from prior cohorts and trying to make sense of it.
That's a good start. Yeah, for a lot of these problems, I don't necessarily recommend watching the videos before you code, but watching them after, like usually what I try to do is like code a problem out and then wait a day, then go back to my code, see if I want to refactor or change anything, and just spend like 5 minutes doing that. And then after that, watching a solution can be pretty helpful. So that's something that I recommend, especially as we get into the more challenging algorithms, which this is just the start. I would highly recommend doing that for a future class, but that's a really good step. Did anyone else have any like opening comments or questions or things they wanted to go over for Boggle before we jump into it? Okay, if not, for Boggle, I'm not going to actually code the whole thing out because that will take up a good bit of time, and we do have a small lecture to go through today. But instead, what I'm going to do is work with everybody collectively to try and come up with some pseudocode for the Boggle problem. Because that is, once you've got the pseudocode down, coding the actual thing itself becomes monumentally easier. So, all right, can you guys see my VS Code okay? All right, cool. And let me just send the link to the Boggle problem in Slack, so that way we all have it, and so that way we can all pull it up and work on it together. Okay, so we start off with a Boggle board. And what do we know about the Boggle board? Well, it's a 4x4 grid. So we might as well write that down for our pseudocode. Boggle board, 4x4 grid, random squares. Okay, so what do we want to do with our Boggle board? What are some features that our Boggle board needs to have, things that we should know about it? Let's just start with like broad things that the problem itself tells us about what we need to do.
Let's shake it.
Okay, yeah. So things we need to do with our Boggle board. And item one is going to be shake it. Okay, so what does shaking it, what is shaking it? What happens when we do that?
We have to fill the board with random uppercase letters, like from A to Z.
Okay, fill board with random uppercase letters. A to Z. Okay, cool. What else? Is there anything else that we need to do? There's only one more thing that I'm thinking of.
You gotta print the board to the console.
Okay, that's another one. Okay, so I stand corrected. There are two things I'm thinking of. This is one of them. So print the board out to the console. And how do we print it out? So what's the layout that we're supposed to use look like?
You need an empty board first, just lines.
Okay, so empty board equals just print lines, and then shaken / full board equals, how do we print the full board?
Now, are we just doing part one where it's just gonna be random, or are we trying to incorporate the dice?
We'll start off with part one because that's how we should do it. And then once we finish part one, we move on to part two. It makes it a lot easier to go part by part for these problems than jumping straight in, especially when pseudocoding too.
Like just a 4x4, like 4 rows, 4 columns.
Yeah, so we'll just print out the 4x4 letter grid. I guess is what we can call it. All right, now there's one more thing that we need to do with our Boggle board. And it's not explicitly stated. But does anyone have any ideas?
Are you looking for having the instance so you can call everything?
Yes, perfect.
Yeah.
So what we need to do is we need to initialize our Boggle board. We need to like make the thing before we can start doing stuff. So I'm going to just reorganize this a little bit in order of priority and in the order that we're going to do it. So yeah, that's probably good. And we'll stop here for now. So this is essentially where we're going to start with our pseudocode. So we figured out what thing we're dealing with. We're dealing with a Boggle board. What are the things we need to do with it? Is we need to initialize the Boggle board. We need to shake it and fill it up with random uppercase letters. And we need to print the board out to the console. All right. So where do we go from here? What should be our next step now that we know what we need to get done?
Find a way to generate those random uppercase letters.
Okay, cool. So we could do that. Or before we did that, let's go like one step bigger. So let's start going from the top down. So what are we going to use to define our Boggle board? Like what type of structure?
Class for the
Perfect. All right, so let's say class Boggle board. And let me just try this. Yeah, this is fine. All right, so we'll just leave it like this right now. So class Boggle board. So what are we going to put in our Boggle board class? And you can see we will get to your comment about the random part really soon because that's very important. But what things does our class need to have in order for us to use it?
We need to initialize the properties.
All right, so we can create an init function. And what goes inside of an init function?
So
All right, do we need anything else for our Boggle board?
possibly, but I haven't, and what I've got, I didn't put anything else in there. I just have self.
Okay, anyone else have different ideas?
For me, I put self.create board and I called the create boards method, but we haven't written that yet together. But that's what I've done. So whenever I create a new instance of Boggle board, it'll automatically show me the blank board.
Okay, interesting. So upon initialization, you told it to call the method, basically?
That's correct.
Cool, okay. But did you put that method in as a parameter, or did you put the method in the init function, or like in the body of the init function?
I think I did it as a parameter. I just did self.create underscore board, open close parentheses.
So that would be
So-
like right up here.
So I put it actually below the method itself for init.
So like right where my cursor is right now.
Yes, that's correct.
Okay, cool. So in that case, it would not be a parameter, actually. What a
Okay.
parameter would be is a thing that we input into the init function. That would be like self, and then you could say like name of board or something. So name of board would be the parameter of the function. Now, what we have inside here, inside of the init function, is basically just the init function or things that we do inside of the init function. So that's all that there's not really a ton to say, but parameters go in the input. Other stuff that you do within the function are not parameters. Does that make sense?
Yes, it does. Thank you.
Yeah, sure. And I think what you're saying is actually a really good idea for calling a create board function. But for right now, we are just going to leave that blank. We'll just say create the board. So just leave it as broad and general as possible. So now, what do we need to initialize any like instance variables for Boggle board above the initialization function, or not really? There's one in particular that I'm thinking of.
I mean, we could put the board itself up there.
Yeah, sure. So how do we do that?
I just did like a list with nested lists in it.
Okay, so how would we write that though?
I didn't put it as a class variable, so I forgot how to do that.
Okay, no worries. Did anyone else end up doing something similar or different?
I wrote a method to create the board, and I used a nested for loop. So that was able to print the blank board.
So was that to print the board though, or was that to create the board, or both?
Oh, sorry, to do both.
Ooh, interesting. Okay. So what you did is like create. So for us, we'll keep it as two distinct things. I'll say create the board and print the board, and then up here, I guess we can. What I personally like to do is define like the Boggle board grid up there, since we have a place for it. So we'll just say like define board grid, and now we need to make our nested lists. So the way that I would do it in this case is I would say something like no, 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 and then basically just like repeat that 4 times. So something like this, because we can fill the no values up later. Oh, and it looks like it has detected that this is Python. Yay! All right. Or nope, it thinks it's Ruby. Oh well. I will not bother fixing that right now. That as long as it works. So this is our board grid. This is our board grid. This is the thing that we'll be playing with. So now in our init function, we need to create the board and print the board. So now though, we need functions that will create and print our board. So we're going to define a, let's call like create board function. And what inputs do we want to put in our create board function?
Self.
Okay, anything else?
Well, the board grid, but why did you put def there for the class attribute?
That is a good point. We do not need def because that's not a function. Thank you, Lizica.
Yeah.
But yeah, we can just leave it at board grid and that should be good. So are there any other inputs that we need for create board at this time? Anything that the user needs to input in order to create a blank board?
Well, you need to pass in the board grid.
That's true, but isn't the board grid something that already exists? Because it's within our class, right?
Right.
So to access board grid, what would we need to do within the function?
Just self.board grid.
Exactly. Self.board grid, whenever we need to access it. So because it's part of the class already, board grid is a thing within the class. We don't need to pass it in as a parameter to our function because we can access it through self, and self is already being passed in as a parameter. Now, if instead, let's say that board grid did not exist within the class. Let's say board grid existed up here. Then self.boardGrid would not work. And instead, I would have to input board grid as something that the user would have to input. Does that make sense? Any questions about that?
So in that case, it can exist on its own in that function, but it can also exist as an instance attribute if you were to use it everywhere.
So that would be a global variable in that case. So it wouldn't really be a class or instance variable. So if it existed within the class, like here, this would be a class variable.
In the init.
So do you mean like a local variable, like something only
Yeah.
within? Yeah, then it would only be used within the function. Just like right now, it can only be used within the class because we're defining it within the scope of the class.
Well, what I'm saying is like if you put it up there next to self def init self and then board grid and then say self board grid dot board grid equals board grid, then we don't need to do it again for the create board method. Right?
Oh, so you mean like by doing
Yeah, like an instance one.
so doing like something like this?
Yeah.
Self dot board grid equals.
I'm just asking if it's okay to do
So-
one or the other or
So I just put self.boardgrid down here as an example where we don't actually need to use that. The best thing to do for create board is just self. But what you're saying is a good question. And this depends on what we're trying to do. So if we think of it, so what you're suggesting is saying, okay, so let's say somebody wants to create a bottle board. So it's like my board equals bottle board, right? Because we're creating a new bottle board. But because you specified board grid here as an input, this means that the user now has to go in and manually type out the blank board grid, which is going to be that null, 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 and keep doing that, which is not great. And that's also not what the assignment here is looking for. The assignment says, when I run my init function, I want to just create my blank board. So because of that, that's why we want to start with board grid already being initialized within the function. So then we don't need to say self.boardGrid equals whatever the user inputs. Does that make sense? Any questions?
yeah.
Okay. Does anyone else have any other questions that are on a similar or a different note before we move forward with create board? Okay, if not, so we're going to just write out the functions that we need for this. So what we're going to say is we're going to have a create board function. We're going to have a print board function, and then we'll have a define shuffle function. So which one of these can we start? We can start with create board, I suppose. So what would we do in our create board function now? So we have a board filled with null values, right? But when we initialize, actually, hang on. We don't even really need the create board function, do we? Because the board's already created. Okay, never mind. The board already gets created for us. So all we really need to end up doing for our init is just printing the board. So how do we print the board? What would I do if I wanted to print it?
You'd want to print each of those nested lists on their own line.
Okay, so how would I write that out? Not in code, but in like programming speak.
Well, you would just do a basic for loop.
Okay.
The contents of board grid and
Perfect. So the slightly more programmer term for this is iterate. So what we would want to say here is instead of saying create a for loop to go through board grid, we could say iterate through board grid. And then we could say print each row. And then from there, you could go and say, okay, whether you want to iterate using a while loop or a for loop, or how you want to print each row. But that's basically what this function needs to do. And it's not really much else to it. Okay, so now comes to the shuffle. So this goes back to what you were saying earlier, Kasib, about bringing in the random letters. How can we do that? Or if anybody did it and really liked the way they did it, would you care to share how you came up with the random letters?
I wasn't sure if we did it correctly, or how it's supposed to be in the assignment, but basically what me and Cameron did is we specifically typed out each side of the dice within one big array. And then we had two variables called random dice and random letter on dice, and then put it into like a random range from 0 to the total number of dice, and then 0 to the number of letters that are on each dice. So basically, when we're going through our shape function or our shuffle function, what it does is it just appends that method that we created to randomly pick a dice and then a letter on that dice, if that makes sense. And
Yeah, that does.
I could totally send it in Slack if I need to, or share my screen.
Oh yeah, if you'd like to send it in Slack, by all means, feel free to. That's a pretty good solution. But I will say that solution works just a wee bit better for step 2 rather than step 1. But that is a very good and efficient solution in order to just pick the dice, and then for picking the dice, you pick the letters. But for part 1, we can actually go even simpler than that. So for part 1, all it's saying is pick random letters. It doesn't really say which letters. They can appear multiple times. So basically what we want to do is for shuffle, what we want to do is like say for each grid square, here, let's say fill each grid square with a random letter. And now we just print the board at the end of shuffle. Does that kind of make sense?
Mm-hmm.
Okay.
Yeah, but
Cool.
then we need to think about how we generate the random letters. Like we probably
Right.
need some help with some importing something.
Yes. So for this, you more than likely would want to import something. And for that, I'm going to go back to Matthew because I'm interested to hear what you imported for the random part.
Do you mean like from random import rand range, or you mean like importing our method into our program? Like which?
So it was more of the former. But what you said is exactly right. So what we want to do here is literally just do import random. So the nice thing about Python is it has a ton of libraries for quite literally almost anything you can think of. And randomness and picking random things is one of those. And we can do that literally just through the import random function. So if we want to pick, let's say, a random number, has anybody tried picking random numbers with Python? Do we know how to do that?
Is it rand int?
Yes, perfect. So what we could do here is we could say like, I don't know, number 1 equals random dot, and you can see if I random dot, there are so many options for things that we can do with random. Here, for example, this will give you a random float between 0 and 1. But what we want is we can do rand int. And that will just give us a random integer within our range. So let's think about this. How can we pick a random letter of the alphabet using this function?
ASCII values?
The Ascii values is one way.
You could create a dictionary and assign each letter of a value, and then when you call it, you can use that to get just a random letter.
Okay. Okay, yeah, we could probably do that. But there's actually an even easier way. So have you guys used the string module before?
Yeah, I ended up using that, and then I did string that ASCII for the uppercase letters, and that gave me, it was basically a list of all of them.
Yes.
Yeah.
So yes, perfect. Good. So this is the easiest solution. So instead of using the literal ASCII values itself and like doing, ASCII value of A plus 1 plus 2 plus 3, which is an option, but it is a far more time-consuming option, or creating a dictionary or a list of tuples, which is another good option. But again, we're dealing with the English alphabet here, so there are easier ways to do it versus if it was like another character set, it would probably be more beneficial. But the lovely thing about Python and the string module is that it has a list of all the letters in the alphabet. And it has lists of them in all cases, in lowercase, and in uppercase. So we can basically just say string.ascii underscore uppercase, and it just tells us what all of the letters are in a string. So we'll just say like upper alpha. So now from here, how many letters do we have in the alphabet?
Twenty-six.
Okay, yep. So we have 26. And now remember that Python is a zero index language, meaning that we start from whenever we have a list or a string, the first thing in that string always starts with 0. So because of that, what is the range that we might want to look at for our random number picker? Because remember, we want to use that random number in order to pick a letter from this alphabet. So what do you think we might want to put as our range for numbers to look through?
Is the end of the range inclusive or exclusive? I can't remember.
It is inclusive.
So then 0 to 25, right?
Yeah. Yeah, see, so it says right here, range AB, including both endpoints. So 0 and 25. So right now we have our upper alpha list, and then random letter. No, do not know where that came from. So here, this will be like our pseudocode for this, basically. Let's put it here, have it out. And then how do I get like random letter from the random number? I've got the random number, and I've got my upper alpha little list or string. How do I get the random letter that corresponds to this number?
With a string, converted with string.
Okay. How, anyone else have any ideas? And that's really close.
Would you perhaps do
Index.
like upper alpha and then brackets and then put rand number in the brackets?
Yeah, exactly. So basically, all the strings in Python are lists. It's not the other way around, but all strings in Python are lists. So because of that, if we want to access, say, like the nth character in a string, we can do that the exact same way we would access the nth element in a list. And we just use our handy little bracket notation for it. So this is how we would get the random number and the random letter. So, and then after that, we would just run our print board function. So this is where I'm going to stop with the pseudocode for now, because we do have a lecture to get through today. Before we stop discussing Boggle, does anyone have any questions about any of the steps or anything that we've talked about in the past 30 minutes?
So what would your next steps? Can you run us through just briefly what your next steps from here? Like in Shuffle, would you just print each one of those letters at the very end where it says print board?
Yeah.
Maybe.
So print board here would basically just run our print board function, which is what we would have defined up there. And then for the print board function, basically what I would do is, again, more so like for each row in board grid, and I would say like for, and I would just say print row separated by spaces. And obviously, I would turn that into something like for a row in board grid, and then just say print, and it would be something like, take out each. Something like print, do an F string. We'll just do like row 0, and close that, and then we'll do a space, and then we can do like row 1. Then just basically keep doing that for each row, so that way it prints out each row on a separate line, because we know that each row has 4 elements. So this is how I would print out the board, basically.
Okay.
Does any other questions? And this would be a sum.
So would that print the board as a nested loop, or would it actually, it's not gonna be vertical, it's not gonna be a gradient, right?
So it would be. So it would be printing
it is,
out
but
each
it's a
row,
loop.
like
Yeah.
1 and then 2 and 3 and 4, like that.
Yeah.
So
Yeah.
it's not a nested loop because this print statement doesn't have any loops in it. But it would still be going like, it would be printing all of these on one line, and all of these on one line, and all of these on one line, and then all of these on one line. And then even if we were to fill these up with different values, it would do the exact same thing for those.
Okay.
Any other questions? Okay, if not, alrighty. So now that we've wrapped up the Boggleboard discussion, we're going to discuss some slightly new things, which are called Dunder Methods. So how many of you have heard of Dunder Methods before, if any?
Is that the methods we've been using with like init or str or what RPR? Yeah, the ones with the
Yes.
double. Okay, yeah.
Also, if you can hear something really loud, that is because there's a helicopter outside for absolutely no reason. So that will probably happen at least once or twice during tonight's session. I'm not sure why, but just in case you can't hear me, that is why. But yes, so init, repr, str, those sorts of things, anything with a double underscore before and after are what we call Dunder methods. So this was probably linked on the curriculum page for today, but there are a lot of Dunder methods that sometimes can be really detailed, and let's be honest, we don't need to go into all of them, but for your own research, if you want to, I highly recommend this link that I'll pop in chat. And yeah, it goes into way more detail than any of us need on Dunder methods and what they call magic methods, but they're there if you need them. But today we're going to work on a little exercise that will help us learn a little bit about what they are and how to use them. So let me go ahead and pop up my screen. All right, so can you guys see my VS Code again in the Python demo.py window?
Yes, sir.
All right, cool. So let me just comment this. So I like solving problems a lot. So that's why tonight's thing is going to be yet another mini problem that will work out together. If you guys do or do not like this format, let me know. And I'll try switching around the lecture format. But if I don't care otherwise, I'll try to keep it a little bit of lecture and a little bit of problem. But today's mostly going to be a problem because I find that's the most fun way to learn about Dunder methods. So you all have been contracted by some random college to create a data structure for their admissions office. And they want you to create a Python class that can help them keep track of their incoming students. So they want things like the name, their GPA, attended major, number of extracurriculars, essay strength, which for some reason they grade on a 1 to 5 basis. I don't know why, but that's how they grade it. And if the student is a legacy admit or not. And they want you to create a couple of methods within your class. They want a quick way to set up a new student, just pop in the information and out comes the class. They want a nice, pretty display of the student's characteristics when we call our print function. I wonder how we can do that. They want some easy comparison of students, like if one student should be admitted over another, or if one student is greater than or less than another from the perspective of this extremely terrible admissions process. And lastly, they want you to check if students have double applied, basically meaning did somebody hit the submit button twice and have the exact same details? So this is where we start. So can you guys help them make this? So where do I go from here? And we're given this giant, what seems like a pretty big task. How do we break this down? Where do we start?
Do class for, ooh, I didn't think this through. Hang on.
Oh, no, you're right. We should start with a class.
Yeah, but I didn't think about what class.
Okay, well, that's a good starting point. So what are some options for what we can make the class for, right? So option one would be we could just make a class for all of the incoming students. Like we could just say like a class for like class of, I don't know, 2027 or something. That's one option, right? The other option, though, would be, remember, we want you to create a class for the students. So what I would say here is because also look at everything that they're specifying. These things are probably going to be harder to write in to a class that just describes like all of their admits, but they would be a lot easier to program if we created a class that just like for like the students who they admit. So what I would say here, and I'm interested to hear if anyone has any different thoughts as well, because this is important and I love discussing this stuff. But what I would do is say something like class, and then it'd be like students applications. Yeah, that probably works. So does that kind of make sense, like where that's coming from? Any questions about that? Okay, I'm going to zoom now. So now we have our class set up, but I'm not going to touch any actual code because the first thing that we do after we start reading over the problem and thinking about what we're going to do is the one thing we do before coding.
Pseudocode.
Pseudocode. Thank you, Elash. So let's get started with that. So how can we write out some pseudocode for this class and for the class methods? So what are some things this class needs to have?
A name.
Okay, so we've got the class name, though. That's the student applications class.
Well, we know we're going to need initialization regardless.
Ooh. All right, good. So initialization function. So we'll leave that aside for now. So what other functions does this class need to have besides the init function?
Student data. So like name, GPA.
Okay, so let's write that all inside of our initialization function. Let's say like init name, GPA, major, number, extra, essay, legacy. So that all goes inside of our initialization function because that's the only way we can set that up.
Okay.
What other things do we need?
You need to display all the characteristics for each student,
Okay, so
like print them out.
yeah, we could do that. So we could call it a print method, but what would be easier, and also we'll see why in a second, we could just call this a string method. So what this would do is it would turn like the class into string representation of the class. So basically, instead of like printing out, like if you were to print a student applications object right now, it would print out some memory address. But what we could do instead is we could have it print out the class or the characteristics of the class in a nicer way. And we'll do that in a little bit once we finish our Pseudo Code. Okay, so what are some other methods that we need to add? There should be 2 more, or 3.
We need to compare between students.
Right. So what's a good way for us to compare things? Like in math, for example, how do we compare 2 values?
Like which one is greater? Like for as far as like GPA or essays?
Yes. Okay, good. What else?
Well, legacy, we can also do that, like a true or false on legacy.
Mhm.
Of course, legacies would get precedence over non-legacies.
Right. So, okay, good. So that's where our comparison method would come into play. So this is where we would, again, compare 2 students and based off of various characteristics that we determine. And there's one more method that we might need.
The double application.
Yes. So double application, or in other words, if one student's application is equal to another. Say if one student is greater than or less than. Okay, so this is where we start. These are our 4 methods that we'll want to kick things off with. So let's start with our initialization function. Well, first off, before we do that, is there anything else that you guys think is warranted that we add here or change? Any questions? Things of that nature? Okay, so if not, let's get started with the initialization function. Somebody talk me through it. How would I initialize an instance of this class? What would I want to do for that function?
Yes, and then or under parentheses self. Yep, there you go. And then you would put all of those variables in there, such as name, GPA, major, or if you want to name them something different, but I would just assume you would want to keep it similar.
Yeah, we can just keep them the same thing. Do num extra, essay strength. And then what I would do instead of saying legacy here is now what also we also want to think about what data types do we want to use? So what data type would the name be?
String.
Okay, string. What about GPS?
Well, that would be a float, wouldn't it?
Okay. And what about major?
String as well.
Okay. And number of extracurriculars would probably be
integer.
Yep. And now the essay score or strength thing.
Integer.
And what about the legacy part?
True, false.
Yes. Or in slightly more computer programming related
Just
language.
be a 1 or a 0.
Boolean.
Or just a weighted value or 0.
Yeah, we could do the weighted value or 1 or 0 as well, but it's generally easier to, if you can use a Boolean, to just use the Boolean. And we're dealing with Python, which it's really nice and easy to use the Boolean. So there, it's probably a good idea to just use a Boolean. Now, something that is a general convention, whenever we have a Boolean value, we generally want to preface that variable with an is. So instead of just making it like legacy here, what I would say is I would type in is legacy instead, because then when we call is legacy, it'll say true or false. So that way, like for the human who's reading or writing the code, will say, okay, this true value says, yes, this is a legacy student, or no, this is not a legacy student. And just instead of just saying the value of legacy is true. So that's just the convention that I like to follow. You don't have to by any means, but I personally find that it makes it easier. Okay.
Zero.
Oh, go ahead.
Yeah, whoever said 0, 1 though, that's actually a really good point, because that can make your comparison method, I think, easier if you're just counting like overall numbers with the student, right? So you could just add up all of the student, compare it that way instead of having like a true or false at the end. It's like a legacy could be like 2 points or something like that. I don't know.
Yeah, that's actually a really good point. You know what? Let's change that, and we'll just say, all right. So instead of Boolean, we'll say,
And just
one.
expanding on that, like, don't we kind of want to, in our pseudocoding now, decide, are we making in our comparison method one score, or are we comparing GPAs and then just comparing like essay strengths, and then I guess, are we comparing just the variables against each other, or are we creating one big score? That's what I was thinking of when we were doing the 0 and 1 thing. But if you're just comparing, are they legacies or not, then I guess it's just true and false would matter. That's the only reason.
Yeah. Yeah.
Yeah, that's a good point. So what system would you guys use to compare these, if hypothetical?
I think that's
Like the total score.
Yeah, okay. So let's write out a comment here and just say add up let's say essay strength, legacy, and extra curriculars, and then GPA is like usually a float, so we'll just say I'll just do like GPA like times 5. I don't know. We can keep it arbitrary. And then we'll basically just say see who scores. So because this function is a little complicated though, what if we just create like a student score function? Because that way we can just call that function instead of running the same thing for 2 students. We can just write this. That will student score function would do all of the adding up and returning the score.
And then if we did it that way, we could have other kinds of scoring functions as well. Wouldn't be just hampered by one. That's kind of cool.
Yeah, exactly. And it helps us a lot with reusability. So that's why, like, whenever you can for a class, it's always a good idea to create your methods like as actual methods outside of functions. So, like, for example, the comparison method here, we compartmentalize it into seeing who scores more and determining the score. We can just pull out determining the score, make it its own thing, and then we can use that later in case we need to, for example, like check if 2 students' applications are the same, or find all the students whose scores are above 50 or something like that. Okay, so I think we're pretty much done with, or actually here for the double application one. Let's do that really quick before we jump into coding. So how do we check if one student's application is equal to another, or if they're both the exact same thing? How would I want to do that?
I mean, if all values were equal between the two.
Perfect. Yes, let's just say check each attribute and whether they are equal for both students or not.
We could also create a student ID, and then
we could do that, but let's say that this college, for some very obscure reason, does not want to make IDs because I don't
have
know.
enough money for that. I get it.
Could you hash them and compare the hash?
Yes, we could do that, but unfortunately, hashes are not something we are covering just yet. We will get to hashes in a couple of weeks, though, and then we'll be using them quite a lot. So for right now, we're not going to be using hashes because unfortunately, that is not the point of today's exercise. But in general, yes, hashes are fantastic for comparing things. Okay. Do you guys feel like we're ready to jump into coding now, or is there anything else that you guys want to try adding into our pseudocode? I'm not going to talk about that. All right. I'm assuming that there is. Boy. All right. Yeah. Something decided to fall off my desk, and it is in the unretrievable place. So I'll grab that during the next break. But let's get started with our initialization function. So what things do we need to put how can we have all the things we need to put into our class, but how do we initialize our class then?
You'll write all the self dot name equals name, assign it to a variable, basically instance variable.
Yeah, exactly. So we're going to do self.name equals name, self.gpa equals gpa, self.major equals major, self.num extras equals extras, self.essay straight equals that, self.legacy equals legacy. Okay, that wasn't too long, which is good. All right, is there anything else we need to do in our initial function for now, or are we good to move on to the string method?
Would it be smart to initialize a dictionary for everything within the init function?
That would be very smart, yes. However, because for some reason the people running this have explicitly banned us from using dictionaries, much like they have banned us from using hashes, unfortunately, we cannot use a dictionary today, because the goal is to make this very slightly tedious. Not too tedious, but just enough. Because it's, yeah. But otherwise, I would definitely either use a dictionary or a list to store all this. Or tuples. You could use tuples too. There's a lot of fun data types that we will get into, but not today. Okay, so let's go ahead and jump into our string method. So this method is a dunder that's really helpful. Here, actually, let me just delete this for now. So let's actually create a student, right? So we'll say student one equals student application. I think that would be S. And let's say name is Joe. GPA is like 3.0. Major is computer science. He does 2 extracurriculars. Extracurricular 4. He is not a legacy. Now, let's say, I'm an admissions officer or something, and I'm using this system, and I come across Joe's name in like my registry. And I'm like, oh, okay, yeah, I want to print out all the information about this stuff. So I'm going to go in and I have some code, and that code says print student 1. So because that printing student 1 should probably, print out the information about student 1, right? So if I run Python demo.py, whoa, this is really weird. Where's all of the information about Joe and his 3.0 GPA and his 2 extracurriculars? I don't see any of that. I see this weird student application object at some sort of hex value. What's going on? Can anyone tell me what happened and what I need to do to fix this?
It's printing its location in memory, and you need to set up a string dunder method.
Perfect. Okay, so how do I set up a string dunder method?
Def __ str __. Perfect.
All right. Yeah. So this is where the string dunder methods come into play, which is exactly what Austin just mentioned. So we don't need to pass it any additional parameters except stuff. But what we do want to do is find a nice way to display this. Now, str methods are kind of a function that we will use that returns a value. We're not going to print anything in our str method, but we will return. And what we're going to return is the thing that we want printed. So for this, what is a nice way to display like the student's information, like in a quick, easy string? How would we do that?
F string.
All right, yeah, let's use an F string. And we'll make our F string. We could do like self.name, and then we could say like self dot I don't know, major. Then we could do I don't know, we could do like qualifications. And we could say something like self dot GPA out of 4.0, and then we could do something like self.num extras, and then we could do essay, and then do like self.essay strength out of 5. And now comes to the fun part. How do I bring the legacy thing into our string here? Because I can't just print, the 0 or a 1. Because a 0 or a 1 doesn't mean anything to an outside viewer. So how can I bring that 0 or 1 into this and translate it into something that tells somebody, yes, this person's a legacy, no, this person is not a legacy?
Would you make a separate method, and then call the method, or would you do it all in that line?
So those are two valid options. Personally, I wouldn't bother creating an entirely different method for this. Okay. But what I think you have a really good idea though. So option A. Oh, go ahead.
Legacy an optional parameter.
So legacy isn't a parameter in this function though. Legacy is something that is within student application.
I mean, up in the def init, legacy equal none, and then you only pass it in if it actually is.
But the thing is, see, legacy is something that they have to pass it.
Oh.
So yeah, so making it optional wouldn't help us in the string method at all, unfortunately. We have to print out whether the student is a legacy or not, based off of the 0 or 1. So how can we do that? Now, Matthew brought up a good point about either writing it out all in this one line or writing it out after. So
can you do a ternary?
Ternary, yeah.
Okay, what is a ternary? I've never heard of this before. How do I write a ternary? What do we do here? Talk me through.
I haven't done one in a while. I think you could do I don't know if it would be return inside the curly brackets, but it would be something like self.legacy question mark, and then an escape character, and then you would do quotations is legacy, and then any quotations, and then full colon, and then another escape character, and then quotations, and then is not legacy or something like that.
Okay, so that is really close. So there's an even easier way to do it in Python. So all we need to do in a ternary is go down here. We have space.
Are we just trying to return a Boolean?
No, so we can't just return a Boolean because it's in this it's in a string.
Oh, okay, so we're printing 0 or 1.
So we aren't printing 0 or 1 though. We need to turn the 0 or a 1 into something meaningful for human beings instead of for computers or programmers.
We're just doing two basically an if else. If we're gonna print one string, F string, if it's true, and another F string if it's false.
So this is where the options come into play. So there's option 1, which is we could define the main F string as like the main body and just define it without having the legacy bit. Then what we could do is we could say the main body, since it's a string, we can concatenate 2 strings. And we could say something like is legacy. And now this is where the ternary comes into. So you could use the question mark and colon parts, or the good thing about Python is we can literally just use if else. So we can just say like is legacy if legacy equals 1, else is not legacy. And then we could just return main body. And this would be a self-done. So does how I did that kind of make sense? So we have the main f string here, which is the thing that never changes, regardless of whether the person's a legacy or not. And then to that, we're going to just add whatever, if they are or are not a legacy, which is another string here based on that ternary.
So the person who's reading this, the user, only sees is legacy or is not legacy.
Exactly, because they will not understand what a 0 or a 1 is. So we need a way to turn that 0 or a 1 into something that they can understand. So let's just make sure this works. So we're going to go back here and rerun our print function. And if we do, we see that this says his name is Joe, he's doing CS, he has his GPA, his extracurriculars, his essay score, and there's a 0, so it says he is not a legacy. But if I change that 0 to a 1, and we rerun it, it shows us that he's a legacy. So this is the way that our str function works. It basically will return the entire class in string representation. And then we can do whatever we want with that string representation. So any questions about the str function right now before we move on to the comparison and score functions? Okay, if not, so for the score function, I'm just going to try keeping it really simple. I'm just going to say compare GPA plus compare GPA plus say, yeah, so we'll just compare the GPAs. Keep it really, really, really simple. So now we don't even really need a student score function. Let's just try doing the comparison method. So how do I create a comparison method using Dunder strings? Has anybody done this before?
Is this where you go into the equal Dunder method and change it?
So this one wouldn't be the equal Dunder method. This one would be
greater, yeah.
Yeah, you'd want to use greater than or less than or greater than or equal to or less than or equal to. But for us, we're just going to keep, again, really simple. We're just going to define greater than. And then this will also be self. Okay. And now we do self. But the thing is, we need to compare it. So because this is a Dunder method that compares this instance of the class to another one, we need to add in another thing here and say like other student. And now what we need to do is this needs to return true or false. So see who has a higher GPA, return true or false. So how can I do that? How can I return true if the student is better than the other, and return false if this student is worse than the other student?
So I guess we would count the student score first, and then.
So we're keeping the student score real simple. The score is just the GPA. Okay, we're just comparing GPAs. There's nothing more to it.
Okay, gotcha.
Just compare self.gpa to other student.gpa.
Okay, how would I do that? So what would I put in the middle? Would it be greater than, plus, modulus?
Greater than?
Yeah, so this would be greater than because, again, we want to check if our student has a higher GPA than the other. We're missing one thing in this. What is the one thing I'm missing here?
Return.
Return, yes. Just remember, greater than function returns something. So just to make sure this works though, let's go ahead and create a new student. Let's call this student student 2. And we'll say that this student's name is, I don't know, Chuck, and his GPA will be a 2 instead of a 3. And he's studying biology, and we'll make it 1, like 5, and this student. So what I want to do now is, we can print student 1, print student 2, and now I want to check if student 1 is greater than student 2. So what do you think I should get? If I ask the computer, is student 1 a better student than student 2? What should it tell me? Should it tell me yes, or should it tell me no? Should it tell me true or false?
True.
Okay, so let's see what happens. If I run this file, we see that we get Joe's qualifications, Chuck's qualifications. As that's true. So indeed, student 1 is better than student 2 because their GPA is bigger. Now, if I try the less than operator, though, because if it has greater than, it should surely have less than, right? Well, in this case, it's false, but that's because the way that it judges greater than and less than is related to memory addresses. But if I try, let's say, student 2 is greater than student 1, should be false, and indeed it is. So our greater than method works. It double checks whether our students' GPAs are greater than or less than each other, which is exactly what we want. Let's see. So now the last one that we have to do is the double check application, or check whether 2 students are equal to each other. And we won't go through this one, but I'm sure you get the idea. But basically all we would do there is basically just define equal function, which is EQ. And we will just call this one other student. And we just do the same thing, basically. So we would just say return like self.gpa equals other student.gpa, and self dot everything else equal each other too. So that's about where we're going to wrap it up for this example. Before we jump into problems, does anybody have any questions about this, or about the Dunder methods, or anything like that?
Would we be able to normally compare instances without using these Dunder methods? Like, I'm trying to remember if we could call up, like, if we wrote a method and tried to identify a different instance, would that work? Is that what these Dunder methods are kind of making happen for us? The ability to do 2 different instances?
So all the Dunder methods are doing for us is they're just letting us use like default functions in Python, but for non-default things. So like the greater than function, for example, that's built into Python. So I can check if a number is bigger than another number, or if one string is bigger than another string. All this Dunder method does is it extends that default method to say I can check if one class object is bigger than the other class object. And it's the same sort of thing with the str method, because it's like, okay, I can print out a number, I can print out a string, I can print out a Boolean, and using the str Dunder, I can print out a class in the same way. So that's what the Dunder methods let us do. Now, obviously, we could do something we could do this without using a Dunder. I could say I could define, I don't know, define like printable version of the class or something. And I could call that self, and then we could just copy this exact thing in there. And now here, instead of printing student 1 or student 2, I would just print student 1 dot printable version of class. And that would do the exact same thing. It would print out same thing that we told it in our str method, but it just gives it one extra step. So the str Dunder method lets us bypass that, writing this function out and then print it. Instead, you just print student 1, and because I have my str method as a default setting, then it'll just print out student 1 automatically as the format that we send. So that all the Dunder methods do is they help us with those default functions and just continue that behavior for our class.
So would it just print out the memory location if you commented out that define underscore underscore GT and then did the student one is greater than student two?
No, so that would not print out the memory addresses. Instead, what that would do is it would compare the locations of the two in the memory and see by some metric which of those memory locations is greater than or less than the other, which is basically meaningless.
Yeah, because it wouldn't translate to the actual GPA numbers that we have.
Exactly, because you never specified. So it's like, okay, you want me to compare these? The only thing I know about them as a computer is the memory addresses. So I'll just do what you told me. I'll compare them by the memory addresses because that's the only thing I know how to compare them to. With the GT method or the LT or GTE or whatnot, you say, okay, I'm not going to compare by the memory addresses. I'm going to do this comparison by some metric that I specify. And then the computer knows that.
So I think I read somewhere that all the operators we have, they're actually those Dunder methods are what make them work. That's what happens under the hood when you do plus and minus. And for plus, it's like an add Dunder method, and for is that true?
Yep, that is. So if you check out the link that I sent in the Zoom chat, so I think I sent it in the Zoom chat, like around maybe half an hour ago, and I'll repost it in the Slack too. This goes into a lot of depth on Dunder methods, way more depth than anybody needs. But it says exactly what you're saying. Every single default method you can think of, plus, modulus, multiply, making something a string, comparison, it's all Dunder methods. So that's where all of that stuff comes from. For even the default methods, they all come from Dunder methods. Okay, are there any other questions before we move on to the problems that you guys have to work on tonight? Okay, so let's go ahead and discuss the problems real quick. So we've got only 2 problems tonight, thankfully, and you guys will have just about 2 hours to work on. Since as stated, I will be ending class just about half an hour early tonight. Now, the first problem, which is kind of nice, is padding an array. So basically, you're going to write a function. It inputs an array and some number, and then an optional parameter. Remember how we use those in our functions. And it basically just adds that parameter onto the array. And there are some contingencies that you'll have to worry about, like figuring out errors and doing unit tests and such. And the second thing that we're going to be doing is doing the Boggle Challenge Part 2, which is the word checker. And you'll be working on both of these in groups tonight. And I will assign those in about 5 minutes. And I'll open up the breakout rooms as well. But for Boggle 2, you want to start with your pseudocode, as this says very helpfully. And we're going to just check for if the Boggle board includes a word that we input that is a 4-letter word. So what I would say is start with pad array, because it's a little bit simpler and a little bit more fun to get started with, and then transition to Boggle 2 after. But yeah, that's what I would recommend for tonight. Any questions about the problems or anything that we talked about before I let you all into groups? Okay, if not, I'm going to go ahead and send out the group pairings in just 1 minute here while I pull these up. Okay. Input you in this. All right, cool. So I just slacked out the pairs. I'm going to create like 20 breakout rooms. And we're going to open all the rooms. So I just sent out the pairs in Slack. So feel free to go into those whenever you're ready. And if you guys have any questions, feel free to let me know. And best of luck tonight.